Good everyone, my name is Graphics. Today we want to solve this problem which says that we should look for the moment of inertia of this figure. Now, what is moment of inertia? Moment of inertia of a body is defined as the product of area or mass and the square of the perpendicular distance of its center of gravity from the axis, right? So, the first thing you do is that you will determine how many components we have here by dividing this figure into the lowest possible division. Now, if I divide the figure horizontally this way, which is the lowest, I'm going to be having two components, which will be component 1 and component 2. What I meant is this, right? Meaning that I've divided it into two. So this is my component 1 and component 2. Now, the height from this component 1 to component 2 is 100. Now, since I have divided it, if I subtract 20 from 100, it means that from here to here will be what? 80. So I'll be having this way. So I'll be having 80 and 20 because 20 plus 80 will give us 100. And still, from here to here is 100. And from here to here is 20. Now, this is what we have here. They are both the same figure. This is the figure. This figure I've divided into two components, right? Now, the next thing we're going to do, we're going to calculate for the center of gravity, right? And there are two ways at which you can calculate for the center of gravity and the moment of inertia. The first way is the moment method, and the second way is the what? The tabular method. Now, in this video, I'll be using tabular method to solve for the moment of inertia and also for the center of gravity. If you want to know more about the moment method, you can just click on this link at the top right corner here. It will direct you to the page at which you can view the moment method, right? Now, the first thing we'll do in tabular method, we need to draw our table. So let me draw the table. So I have drawn my table and I have 1, 2, 3, 4, 5, 6 columns and I have 4 rows, right? So my first column should be the column for the components, right? So if you notice it, we have two components. So let me put it in. So the components, and we have the two components, 1 and 2, and both are rectangular in shape. So we have rectangle 1 and rectangle 2. So let me put that. This is the rectangle 1 and the rectangle 2. Right? Now the next one should be to calculate for the area. So I have the area, A R E A, area in millimeter square, right? Now the next one for the area, the next one should be for the centroidal axis, right? So I can put it, the centroidal axis is also given as the center of gravity along x, so I'll put it this way, center, or better still, centroidal axis, right? That is the center of gravity along x axis, right? And that is in what? In millimeter. Is that again? Now the next one will be still the centroidal axis, and and that will be the center of gravity along y-axis, right? Also in what? In millimeter. Now the next one we're doing here will be the area of, that is multiplying the area and what? And the center of gravity along x-axis. So we'll call it a what? Ax, right? And that's going to give me, that will be in what? In millimeter cube. And this one will be what? Ay in millimeter cube, right? Now what we'll do now, we'll start for the area of the figure 1, rectangle 1, which is this. We have just, this is the length and this is the breadth here, or the width, or let's say the height and the width. Is that taken? And we're saying 100 times what? 20. We have the 100 multiplied by what? 20, and that will give us 2000 millimeter square. So I don't have to write it because it's already here. And the area of the figure 2 is given as 80 times 20, right? So we have in 80 multiplied by 20, and that will give us 1600 millimeter square. Now we're done with the area. Now the next thing we'll do is the cylindrical axis along x-axis of the figure 1, the rectangle 1. This is the rectangle 1 here. So we are going along x-axis, right? This is x-axis, and that is 100. So since rectangle 1, we'll call it the distance along x-axis of the figure 1, and that will give us this figure, the length of the figure I'm considering, all over 2. Because I'm considering this figure 1, that is why I'm dividing it all over what? All over 2. And that will give us what? 50. I don't have to write the millimeter because it's already here. Now we move to x2. x2 means I'm considering the second figure, that is rectangle 2, right? So the distance along x. Now if you look at this very well, right, this is x. X is going towards this direction, right? We're moving this direction, and the figure 2 has 20, so I'll put 20 there. All over what? All over 2, because I'm considering. And that is not the end, because there are spaces here before I get to this 2. Now I need to know the distance of the spaces here. Now if I remove 20 from 100, right, I'll be left with 80. And if I divide that 80 into 2, that means from this point straight down to this point here, right, it's giving us what? 40. And from here also straight down backward here is also giving us what? As 40. That means this is 40, 40. In between is the figure 2. So before I get to this figure 2, I will travel a distance of what? 40. So that's the first I'm going to add there, plus what? Plus 40. And this will now give us 20 divided by 2 will be 10. 10 plus 40 will give us what? 50 millimeter. Is that okay? Now the next thing I'm going to do here is the central axis along y. That means I'm going on a vertical manner, right? And this is the baseline here. This is the baseline here. So if I'm moving for figure 1, I'm starting from the ground floor here to here, right? So I'll call it, since I'm going along y, so this will be what? Y1. Along y, figure 1, component 1 means y1. So that means I'm going up, since this figure 1 here is relying on 80, right? So that figure 1, the height of figure 1, look at the height here, that is 20. So I'm going to put 20 all over 2. Whatever figure I'm considering, I'll divide it by 2. So figure 1 along y-axis, the vertical axis is 20 for figure 1. So I'll divide it by 2. Now before I get to figure 2, I'm going to travel a distance of what? Of 80, right? So what plus the distance I'll travel. And that's going to give me 20 divided by 2 is 10. 10 plus 80, that will give me what? 90 millimeter, right? And the next one is y2. Now if I travel for the y2, this is the ground floor. I don't have to go any distance if I get to y2. You just get in. This is from my y2 from the ground floor here to this point here is 80. So it will just be what? 80 divided by 2, and that gives us what? 40 millimeter. Is that okay now? Now the next thing is I'll multiply the area and the distance along x. So this area here, right, is 2000 multiplied by the distance of the figure 1, which is what, 50, right? And that's going to give us what, 100,000. 100,000. The same thing here also, ay, 2000 times 90, that gives us what, 2000 times 90, and that's going to give us what, 180,000 millimeter cube. Similarly here, 1600 times 50 is going to give us, so that will give us 80,000. When you multiply 1600 times, that is 1600 times what, times 50, and that will give us what, 80,000. Right, and the next one will be 1600 times 40. 1600 times what, times 40, and that's going to give us 64,000. Right, so in doing that, we've gotten the 64,000. Now the next thing is we're going to look for the summation of this figure here. So we're going to sum this, and we're going to sum this. So the summation, right, of ax, right, and that will give us 100 plus 80, that give us 100 and what, 80,000, right? And the summation of ay is going to give us 180 plus 64, and that is going to give us what, 200 and what, 244,000. That gives us 244,000. Is that okay? Now we've gotten the summation of this, or we've gotten the summation of that. Now the next thing is the summation of the area. So we're getting the summation of what? Summation of what? Of A. And that will give us 3,600. 3,600. Right? So from here we've gotten all what we need here. So we know that we'll now write it this way, that the we'll move forward. Let me take this upward this way. So we'll come here and say that the moment, the center of gravity along x-axis will give me the summation of what? Of ax all over what? The summation of what? Of a. And that is going to give us summation of ax is 100 and what? 80,000 all over what? 3,600. And that's going to give us what? 50, right, millimeter. That is the center of gravity along x. Similarly, for y, the center of gravity along y, let me just do it here, along y, it is going to give us the summation of ay, right, all over the summation of a, which is the area, and that's going to give us 244,000 all over what? 3,600, and that's going to give us 67.78. that gives us 67.78 millimeter. So this is the center of gravity of the two figure, right? Now we move forward. We have successfully calculated for the center of gravity of the figure. Now we want to calculate for the moment of inertia. Applying theorem of parallel axis, we say that the ix is equals to the I plus the area multiplied by what? H square. Now sometimes some textbooks might use y asterisk to represent h, but we are saying the same thing. Now if I should write this again, this can be giving us I is giving us what? BD cube all over 12 plus A into brackets. We're talking about, if I'm dealing with IXX, it will now give me y minus what? Y bar. So this is what we have here. If I'm talking about, if it's for IXX, so if I'm talking about ISS1, that is the moment of inertia about XX of section 1, it will be Y1, A1, right? So if I'm dealing with IYY along section YY, it is going to give me the BD cube all over 12 plus A into bracket X minus what? X bar. There's a square here and there's a square here. So it can be this. It can also what? Be this. Is that okay? So let's apply it into our equation here. Now since we have from here, since we have two figures, so we mean that my IXX will give me IXX1 plus what? IXX2. Because we have two figures given in the question here. That is rectangle 1, rectangle 2. Right? So I already say for my IXX. So if I should write this, this will now give me for IXX1 from the formula, we say that this will now give BD cube all over 12, right? Plus we have the area. We're talking about ISS1 now. Let's not move forward. That is my ISX, right? So this is BD cube plus, since ISS1 will be A1 into brackets Y1 minus what? Y bar all square. That is for ISS1 plus this. That will give me ISS2, give me the BD cube all over 12 plus A2 into brackets Y2 minus what? Y bar all square. So this is what we have here. So if I start inputting my formula, so this is for ISX, then what about for IYY? Let me call this to be my equation 1 for ISX. So for IYY, that is the moment of inertia along section YY, will now give me IYY1 plus IYY2, and this will give me, we have the BD cube all over 12, that's for IY1, plus, now we're dealing with, this will still give me A1 into brackets. Since I'm dealing with IY, this will now be AX1 minus what? X bar, because we're dealing with what? Y, plus this will be square, plus we have the BD cube all over 12 plus A2 into brackets S2 minus X bar all squared. This is my equation 2. So this is my formula here, my general formula that we are going to use. So we're going to start using them one after the other. So let's start and see. So from equation 1 here, we say that from equation 1, we say the IXX will now be equals to, what is B? B is the base. So that means XX means sectioning along XX. So let's move forward. Let me just write out the formula out first. IXX will now give me BD cube over 12 plus A1 bracket Y1 minus Y bar all square plus BD cube over 12 plus A2 bracket Y2 minus what? Y bar all square. Now let's start inputting our value from that equation here, and we'll see how that goes. So from here, if I section this figure here, this will be XX. So if I section here this way, it means along XX, right? So that's my ISX. So the side opposing that is parallel to my axis is the base, right? And what's the base? That will be 100. So I'm going to be having 100 multiplied by, now we have the D means the depth, and that will be 20 all cube all over 12, right? Plus the A1 from here, this is area 1, which is 2000. So I'll place it there, 2000 into bracket Y1 is the Y1 90 minus Y bar, that is 67.78. We have 67.78, close the bracket, plus BD cube. Now if you look at it, now we're dealing with Y now of the same figure 1, right? We're still dealing with X now. So I'll go to figure 2 because that is ISS2. So if I section it along X this way, we're dealing with X, this is X and this is X. So the side parallel to my X-axis is 20. That is this 20 here. So that will be my base, right? So the base is always parallel to the axis. So the base here will now be 20. So we're having 20 multiplied by the depth now will now be what? 80. That will be 80 cube all over what? 12 plus A2. The area 2 here is given to be 1600. So we have 1600 into bracket y2 is given as we have 40 minus the y bar, which is 67.78. It doesn't really matter whether it's giving you negative or positive, the power will indicate the negative sign whatsoever. So we move forward, and this will now give us, we'll start by saying 100 times 20 cube divided by 12 will be 6.67. That's what we have when you do this. Plus, if I subtract 90 minus 67.78, it's going to give me 22.22, right? So I have to what? Square it from the formula here. So square, and that will give me, that is 2000 into bracket 493.73 plus 80 cube times 20 will give us 10240,000. That is 1,240,000 divided by 12, and that will give us 85333 plus 1600 into bracket 40 minus 67.78. If I square it, it will give me 771.728. Now if I move forward, I'll be having 66666.67 plus 2000 times 493.73. That gives me 987460 plus 85333 plus 600 times 771.728, and that'll give me 1234764.8. Now we're going to add everything together. In doing that, I'll be having 6066.67 plus 987460 plus 851233, that is 3333 plus 1234764.8, and we're having this to give me 3142224.47 mm to the power of 4, right? That is what I have for my IXX. Is that okay? Now similarly, we'll do the same thing for IYY. From what we have here, the IYY here is giving us this formula here, which I'm going to write. So from here I can put it this way and say that similarly the I along section YY, the moment of inertia along section YY, will be equals to BD cube all over 12 plus A1 into brackets. I will now put this to be x1 minus x bar all squared, just like what we have here. This is what I'm rewriting, plus BD cube over 12 plus A2 into brackets x2 minus x bar. That is the moment here. So if I move forward, I'll start sectioning along YY. So for YY, for figure 1, we're dealing with the first one is for figure 1, right? So if I go to figure 1, if I section this rectangular figure, this here, if I section it along Y, right? I'm sectioning it this way. This is YY, right? So it means that this will be the base. The height will become the base. And what is the base there? The height here, this is 20, so it becomes the base. So it will now be 20 multiplied by, then the depth will now be the 100 cube all over 12. Then plus A1 here given to be 2000 in bracket x1 50 minus x bar 50 plus, now this is square here, we have BD cube. We're talking about the second figure, figure 2. So if I section along YY along this figure 2 here, the one parallel to the YY as will become my base, and what is parallel to it is from here to here, and that is 80. So it will be 80 multiplied by 20 cube, right, all over 12 plus A2 is giving us 1600 into bracket x2 is giving us 50 minus x bar, that is also 50 all square. So what I have here This will now give me 100 cube times 20 divided by 12. We have the 100 cube times 20 divided by 12. That will give me 6.67. Then all this becomes 0 because 50 minus 50 is 0. 0 squared 0. 0 times 2. This just remains. Everything here becomes 0, right? So plus 0 plus 20 cube times 80. 20 cube times 80, right, divided by 12, and that will give me 53333.33 plus everything will become 0 because 50 minus 50 is 0. 0 squared is 0 times 1600 is 0. So we now see my IYY here. Put it this way, my moment of inertia along section YY will now give me 1666666, right, 0.67 plus 53333.33, and that will give us 1720000.003 mm4, right? So that is what we have for that question. The moment along section YY is this, the moment of inertia along section Y is this, and moment along section XX, moment of inertia along section X is this. So that's what we have there. So if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.